Okay, today's guided notes is on literal equations. You should have a paper that looks sideways like this, but we're going to go ahead and rotate that paper, and I'm going to be working it out like this. So if it looks a little bit small, sorry, it's just that's the only way I can do this so that we can kind of follow along together. So it says literal equation guided notes. A literal equation, let me go ahead and get the right color, a literal equation typically is only letters or variables. So this is going to be a little bit different from what you're used to because there's not going to be as many numbers. So I want you to think of formulas that are used like either in your science class or math class. These typically are literal equations. Some examples are like A equals L times W or E equals MC squared. Solving literal equations is just like solving regular equations, except that you aren't eliminating or simplifying any numbers. You are literally just isolating the variable. So if we can get good at this, then we get a really good stronghold on how to solve equations. Okay, if we can solve it when it's just letters, then it's going to be super easy when we have numbers in it. All right. Um, the important thing about this, though, is when you're solving for variables, we are going to be literally doing the opposite operation to cancel stuff out. Okay. So I want you to like right here, we are going to be doing opposite operations. For some reason, because I had to make this sideways, this is going to happen a lot. You see that random line that just happened? It's going to do that a lot just because, again, I had to tilt this sideways and it does some really weird things. So this is me trying to mess around with it right now. I'm trying to get this to act accordingly. There we go. Opposite operations. And again, that's going to happen a lot just because I had to tilt this paper sideways and it does weird stuff. Hey, this lesson today, in order for us to solve, we need to do opposite operations. And sometimes the operations are going to be easy to see. Sometimes the operations are going to be invisible. Sometimes we have to do stuff prior to doing it just so we can get stuff done. And I know I said a lot of random stuff right now, but you'll see them as they go along. So I want to solve d equals r times t for r. So let me go ahead and highlight that I want this r by itself. Now, right now, if I were to split this equal sign down the middle, if I want to get r by itself, it's not by itself. We're going to say we're going to isolate the r. I need to get rid of that t. What's happening with that t? Well, I don't see an addition, a subtraction, a multiplication, or a division sign. I just see RT. You need to know that when two letters are stuck together like that, there is an imaginary dot in the middle of those two letters, which means multiply R times T. For example, if I told you T was 7, you would put R parentheses 7, which means you are multiplying the R and the 7. So understand that they are multiplying R times T. And remember, to get rid of the T, I need to do the opposite operation. You know what? We should probably write that too over here on the side. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. Usually when we do division, we don't put a division symbol. We actually do like a fraction, okay, because a fraction is also a division problem. And then the opposite of division is multiplication. Whoa, 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 whoa. I got a little ahead of myself there. I was thinking of what was going to happen next. Okay, those are the four main ones, but really we should know at least one more. The opposite of squaring something is square rooting it. And we're going to talk about that more in depth later as the year goes on. And then obviously, well, then the opposite of square rooting. Oh, I think my iPad's going to do that weird thing again. It sure is. It's going to freak out on me. And so let me go ahead and try to get this back to normal. Opposite of square rooting is squaring. Okay, now that I have all my opposite operations here, let's go ahead and solve for this. Remember, I'm trying to get r by itself, and I need to get rid of that t. We are multiplying by t. That means to get rid of the times t, I need to do the opposite. I need to divide by t on both sides. That means that times t and that divided by t are going to cancel each other out, and we're just going to be left with the letter r. And then when I write d divided by t, instead of writing it like that, because we really don't write it like that in mathematics, we usually write it like this. Remember I said that division is usually written with a fraction. So you know that if you have a fraction, really what they're asking you to do is divide, which is super important when we come up to the next problem. I want to solve for y in this case. It says solve x equals y over z, but I want to solve it for y. So let me go ahead and highlight the y. This is the one I want to get by itself. Right now, I know I am dividing by z. If I want to get rid of that dividing by z, I need to do the opposite operation. The opposite of division is multiplying. So I'm going to multiply both sides by z. I wish they gave me a little bit more space, so I'm actually going to write it over here because I don't like that. X equals y over z. To get rid of the divide by z, I'm going to multiply both sides by z because that's the opposite operation. These are going to cancel because when you have opposite operations, they will cancel each other out. And notice that I have zx is equal to y. I can also write it as xz is equal to y. Did you notice that I did not put the dot? Remember that if there is no symbol between the two letters, we assume that there is a dot. So I don't need to write it for me to know that it's there. Okay, this next one is a little complicated. It says solve u equal to kx plus yx for x. Now, the problem here is I have two x's that I'm solving for. Do we see those two x's? If I could combine them, I would. Except in this case, I can't. So what we're going to do is we're going to do the opposite of distributive property, which is to factor. It's just distributive property, but going in the opposite direction, okay? So if you see two of these side by sides with an addition or a subtraction problem next to it, I just need you to understand that it's going to be the opposite of factoring. What do I mean by that? Well, if I were to have x in front of my parentheses and then put a k plus y, like this, what would you do with that x? You would distribute that x, and you would go x times k is equal to xk, or I can write kx, same thing, plus, and then you would distribute the x again, and then x times y is equal to xy, or you can write it as yx. What am I saying? I'm saying that we were given this, and I can go backwards to this. So it's distributive property, it's just I'm going the opposite direction. Notice that this thing is the exact same thing as this thing. They both have an x in it. So I can take that x and put it in the front. When I take that x and put it in the front, all I'm left with, that's like taking out the x here, taking out the x here, and I'm just left with the k plus y on the inside. We call that factoring, okay? Okay, now that I factored, the whole reason that I'm doing that is now I don't have two x's to solve for. I just have that one x. And what's happening with that one x? Well, it's being multiplied by that k plus y. And if I can get rid of that multiplied by k plus y, I can get x by itself. How do I get rid of multiplying k plus y? Well, we're going to divide both sides by k plus y. And I'm going to go ahead and write this in parentheses. I don't like the way it's written here. I'm going to divide both sides by k plus y. And when I do this, the k plus y's are going to cancel. And that just leaves me with the u. whoops, that's a y, a u divided by a k plus y. That one is tricky, I do understand, but you are going to see quite a few like that. So I think the more we practice it, the more you're going to understand it. All right, let's go ahead and jump into the 9. Ooh, is it 9? It's 12 problems. So since there's a lot of problems, I'm actually going to go a little bit quicker than I've been doing in the last one. It says solve g equals x times c for x. So this is the one I want to get by itself. What's bothering that x right now? Well, there's that times c right next to it. Remember, there's an imaginary dot. What's the opposite of multiplying by c? The opposite of multiplying by c is dividing by c. I'm going to divide both sides by c. These c's are going to cancel. That's why I'm doing it. The x is going to be left by itself. And on the left-hand side, you just have a g divided by c. This is my final answer. All right, let's take a look at another one. This one says solve 12ab equal to 4 for the letter A. Here is my letter A. There is a couple of things happening with this letter A. First, it's being multiplied by 12, and it's being multiplied by B. Notice that I'm putting those imaginary dots. So I'm multiplying by 12 and by B. I'm multiplying by 12b. How do I get rid of multiplying by 12b? I got to do the opposite. The opposite of multiplying by 12b is dividing by 12b. These are going to cancel. Notice that everything canceled. The 12s canceled, the b's canceled. I'm still left with that a is equal to 4 over 12b. Now, normally I would say I'm done, except we see that that 4 over 12 is just a regular fraction. And 4 over 12 does simplify by 4 on the top and on the bottom. So if I divide the top by 4, that becomes 1. If I divide the bottom by 4, I get 3b. The 4 over 12 simplifies to 1 over 3, and this is my final answer. Okay, next one. Solve am equal to n plus p for the letter A. It is so important that you understand what it is that you're solving for, so that way you know what you need to get rid of. I'm trying to get that letter A by itself. Right now it says am equals n plus p. Because that looks kind of convoluted, let me go ahead and write this on the side. Am equals n plus p, and remember, we're trying to get the A by itself. Well, right now, the only thing bothering the A is that times m. Remember, there's that imaginary dot. I need to get rid of that times m, which means I'm going to do the opposite. The opposite of times m is divided by m. I'm going to divide both sides by m. The reason I'm doing that is now I can cancel out those m's. I'm just left with the a, which is exactly what I want. And on this side, I got n plus p over m. And it looks like I cannot do anything else with that. I am stuck. All right, we got the first 3 done. Whoa, 9 more to go. Yeah, we're going to speed this up, guys. Here we go. Let me write this again. I got g equals x minus c plus y, and I'm solving for the letter x. This is the one I want to get by itself. I'm going to do this in 2 steps. I like to get rid of the stuff that's furthest away first. So the thing that's furthest away, and remember, I'm talking about this equal sign right here. I need to get x completely by itself. I see a minus c and a plus y. Let me get rid of that plus y. How do I get rid of a plus y? We do the opposite. I'm going to subtract by y on both sides. Now, when I do this, g minus y, I have no idea what that is. So I'm just going to write g minus y is equal to, on this side, these are going to cancel out. I still have that c though. So this is going to be x minus c. Now I want to get rid of the minus c. How do I get rid of a minus c? I do the opposite. I'm going to add c to both sides. Again, I can't really combine these things. So these are going to cancel out. On the right, let me do on the left side because I'm running out of space. G minus y plus c, because I can't combine any of those, is equal to x, and that's exactly what I wanted. And there goes my laptop or my iPad freaking out on me. All right. G minus y plus c is equal to x. Let me go ahead and write this again. I got xm equals x plus z, and I want to solve for x. Well, here's my, oh no, I got 2 x's. This is a z. I'm going to put a line through it so I don't think it's a 2. Hey, when you have 2 x's, somehow you have to find a way of putting those x's together. So right now they're on opposite sides of the equal sign. I need to get the x's together somehow. So let me go ahead and move this x over to the left. And I know there's going to be some confusion here. Some of you guys are going to see, oh, the xm, and I can take away the x, and the x is going to cancel. That's not true because it's not a regular x. This is an xm, and this is an x. These are not the same type of thing, so you cannot combine those together. They will not cancel out. You're going to write this as xm minus x is equal to z. Okay. Hey, I'm still running into the same problem. Like, I'm one step closer. Notice that both my x's are on the same side of the equal sign, but I still got two different x's and I can't combine those. So now the question becomes, what do I do? This is the same type of problem. Remember I said we're going to do this quite a bit. If you can factor out an x, factor it out. We are going to factor out an x, which means I'm going to do the exact opposite of distributive property. I'm going to bring an x out to the outside, parentheses. Now, how do I get this back? If I went x times what is going to give me that xm, that'd be an x times m minus, and then x times what is going to give me that x? Well, that would have to be a 1. Sorry, I just realized that should have been an m. X times m gives me xm. X times 1 gives me a minus x. Now I have this set up correctly. I have an x, just one of them, being multiplied by m minus 1. To get rid of it, I'm going to divide both sides by m minus 1. These are going to cancel. I get x equals z over m minus 1. All right, this one's way easier. I'm solving this one for a. Let me go ahead and rewrite this again. And actually, let me make my writing a little bit thinner, just because I think it's too bubbly right now. I got g equals ca minus b, and I'm trying to solve for a. I got two choices. I can either get rid of the times c, or I can get rid of the minus b. Hey, your very last step every single time is to divide by the coefficient. At the very end, whatever the number is in front of that a is what I'm going to get rid of. So if I'm going to do that at the end, that means I need to get rid of the minus b first. I'm going to get rid of that minus b. How do you get rid of a minus b? You add b to both sides. I can't add g and b, so I need to keep those separated. G plus b is equal to c times a. Remember, when there's nothing in between, we assume that's a dot. How do I get rid of that times c? I'm going to divide both sides by c. These are going to cancel, and I get g plus b over c is equal to a. All right, halfway done. Oh, this one is, I don't know why these are in such a random order. Like, some of these are really easy. Some of these are way more difficult. On this one, I want to solve for b. Well, I just need to get rid of the times h. So divide both sides by h. These are going to cancel. I get a over h is equal to b, and we are done. I like problems like those. Those are easy. Let's see. Solve p equals 2l plus 2w, and I want to solve for w. Now, again, there's a lot of things going on, right? I like to work with the stuff that's furthest away. So it looks like I'm adding two w's here. That's way far. Remember, we're going to get rid of that 2 at the very end because it's a coefficient. How do you get rid of adding two l's? You're going to subtract two l's from both sides. These are going to cancel. I get p minus 2l's is equal to 2 w's. How do I get rid of that 2 in front of the w? Remember, there's an imaginary dot there because there's no operation. So then that's a times 2. To get rid of the times 2, we're going to divide by 2. These are going to cancel. I'm left with p minus 2l over 2 is equal to w. Sorry, I just got in the habit of writing the problems over again, so we're going to go ahead and do that. Q equals c plus d over 2. I am solving for d. All right, this one is a little complicated as well. I see that I have this adding c and this dividing by 2. Now, the other way you can think of this is reverse order of operations, which means if you were to plug in numbers here, what would you do first? Well, I would add these numbers and then divide by 2. Okay, well, we're going to do reverse order of operations. So at the very end, it said divide by 2, so I need to get rid of this divide by 2 because that's the last thing I did. Okay, how do I get rid of a divide by 2? I multiply both sides by 2. These are going to cancel. I'm left with 2q is equal to c plus d. Remember, we're solving for a d, and right now I'm adding c. So to get rid of an adding c, I'm going to subtract c from both sides. These are going to cancel. 2q minus c I can't do, so I'm going to write this as 2q minus c is equal to d. And we're left with 3 more, almost done. It says solve q equals 3a plus 5ac for a. Okay, this one is very, very detailed. Let's see. Q equals 3a plus 5ac for a. Again, I got this a here and I got this a here. I would love to combine them, but 3a is not the same thing as 5ac. If that would have said 3a plus 5a, I can put the a's together and say, oh, there's 8 a's. But because the first one's a 3a and the second one's a 5ac, those are different things. I cannot put them together. Okay, what's the trick we've done when we see two variables like this? Well, we've factored them out. Okay, so let's go ahead and factor out the a, parentheses. There's a couple of ways you can factor. I just noticed we could have done this as well. If I got rid of the a and got rid of the a, what would I be left with? Well, I'd be left with a 3 plus a 5c, and that's exactly what you're going to have in the middle. 3 plus 5c. Look what happens when you distribute it. A times 3 is 3a. That's exactly what we have. A times 5c is 5ac, and that's exactly what we have over there as well. Okay, so yeah, that's probably the easier way of doing this problem. Now we're going to be really, really smart and realize I'm trying to solve for a, and right now I'm multiplying by all of this, which is a 3 plus 5c. So how do I get rid of multiplying by 3 plus 5c? We're going to divide both sides by 3 plus 5c. We're going to divide both sides by 3 plus 5c. These 3 plus 5c's are going to cancel, and you're left with q over 3 plus 5c is equal to the letter A. All right, down to our final two. It says solve L equals Pn over Rn plus A. Okay, I can tell you right now, this is easily going to be the toughest one, so try to stick with this one, okay? L is equal to Pn over Rn plus A. Unfortunately, there's two really weird things going on here. I have an n on the bottom. We do not like our variables on the bottom. And the only way you can get rid of variables on the bottom is to multiply both sides by whatever you have as a denominator. So my very first step is I'm going to multiply both sides by the denominator. I'm going to multiply this side by Rn plus A. And I'm going to multiply this side by Rn plus A. These are going to cancel. I'm left with Rn plus A times L is equal to Pn. I got a couple of problems here. I have that L right next to that parentheses, and I have n's, which I'm trying to solve for on two different sides. So in order for me to move the n's to one side, I need to distribute that L first. Let me go ahead and distribute this L here and here. I get R N L plus A L equals P N. Okay, I still have the n's on two different sides. So now I'm going to go ahead and get rid of this plus RNL. I'm going to subtract RNL on both sides. Man, guys, this is probably one of the more challenging problems I've seen like this. I believe even a lot of my college students would have trouble with this one. So just do your best on this. I don't think you're going to see too many like this just yet without a lot more practice on it. So I'm pretty sure it's not going to be on the homework, but let me just go ahead and show you what it would look like anyways. Subtract R and L on both sides. I get AL is equal to PN minus RN L. Now I have my n's on the same side, and we're going to use the trick that I did before. Hopefully you remember the trick, and that is to factor out the n. So I get AL is equal to, if I factor out the n, I'm going to have a P left over minus an RL. Finally, I can get that n by itself by dividing both sides by that P minus RL. Divide both sides by P minus RL. These are going to cancel, and I finally get AL over P minus RL is equal to n. I don't know why this problem is here, guys. I think in regular class notes, I'm just going to skip it because that problem is way too difficult. All right, we are down to our last one. And then, of course, they do give me like an easy one. What the heck is going on here? P equals A plus B plus C, and I want to solve for B. All right, I mean, after the last one, you're going to look at this and going, oh my gosh, that's it. Remember, I'm adding A and I'm adding C. Let's just get rid of one at a time. I'm going to get rid of the adding A by subtracting A. These are going to cancel. I get P minus A is equal to B plus C. Almost have B by itself. I just need to get rid of the plus C. I'm going to get rid of that with a minus C. These are going to cancel. And then I have P minus A minus C is equal to B. And that is the notes for today. I know that was pretty long. Thank you for sticking through it. And as always, if you have any questions, feel free to ask.